Okay, so I've been playing around with a Godot slash Blender add-on created by this fella, Michael Jared. So this is called the, let's see, what's it called? Where am I? The add-on is called Godot Pipeline. I've been using it quite a bit the last couple days, and I found it very, very helpful with my Blender to Godot workflow. So check out the add-on. It's made by Michael Jared. It was part of the recent Blender Humble Bundle deal. I don't know if that's still going, but it's $5 over at Blender Market. I'll have a link in the description for it. Really cool dude. Help him out. Again, I think the add-on is very worth it. And I also stumbled upon this Twitter post by Pixter, who, if you've been using Godot, especially doing 3D in Godot, you know who this gentleman is. And he recently asked, what would be the best way to get Blender geometry nodes instances into Godot? Let's say I have a landscape with shrubbery and grass placed by geonodes. How do I get their transform data into a Godot multi-mesh? So the stars aligned. This is something I was recently playing with, the Godot Pipeline add-on. Michael actually just posted a video to YouTube today. Version 2.2 is either out or it's coming out very soon. So again, it seems like a good time to talk about this, and I think I'm in a position to chat about it because I think I answered this question. Well, I did answer this question. I know that I have a workflow that works. So enough rambling about this. So let's get into a scenario. So I have this scene created with geometry nodes. So let's take a look at the scene. Okay. So I have a simple landscape. It's a 3-tiered platform. But it's interesting because this landscape, let's go into a mode where we can kind of see this data. So the landscape is mirrored, right? So you can see that there's a sort of symmetry here. And this is probably a better demonstration of like a final product. Let's look at the baked version. Yeah. So here's kind of the idea. I've got a 3-tiered landscape. It's symmetrical. I can add like a road that goes from one side to the other. So it's similar to, a MOBA or an RTS game where you can have two teams and they have, access to the same resources because everything is basically mirrored like this. This isn't the important part. The important part is, let's say I've got this whole geometry node set up, and I have my shrubbery, as Pixter referred to it. So I have a bunch of these grass / cacti blades, right? And they're spawning throughout the scene. You see that they're spawning on all 3 levels. And being geometry nodes, I have it parameterized, parametric. So I can change a bunch of these settings. I can say, let's go back up top and change the seed, right? Something that, is doable probably in engine in Godot or through some other means. But to me, this is a perfect use case for geometry nodes. I don't know if I could do it without something like geonodes. Or at least not very easily. I can set, let's see, the density, so I can have more and more cells. So I'm pretty happy with this. This is basically what I wanted to do. And you see if the cells are too small, I end up removing them. But let's do this with a simple example. Let's do something like this. Simpler example, maybe let's go even smaller. Okay. In this case, the data that we want to convert to a multi-mesh is not symmetrical. It could be. I don't really care. It's just random shrubbery. But what I have is I have this prime grass instance, right? Grass prime up here. And the other thing you'll notice is the origin is shifted a little bit so that when I'm actually spawning this on my, faces and geometry nodes, I know that it's going to clip through the face a little bit. So there's not going to be any weird stuff where, the bottom of this is exposed or anything. It's always touching and it's always clipping through a little bit, right? Which in my context, that's what I want. Yeah, there's overdraw probably, who cares? So let's look at the actual node setup. I know I'm rambling quite a bit. I just want to provide some context so you see what we're trying to do. So again, we want all of these grass blades we want to export all of this as multi-mesh data, but we want to preserve the variations in scale, in rotation, all that good stuff. So let's look at the node setup. Okay. So this is a pretty complex tree. It's not organized very well. I haven't grouped things or added notes. So don't learn geometry nodes hygiene from me. None of this stuff is super important. So all of this is, these are all nodes in order to provide the platforms, to provide the ground, right? Make sure it's symmetrical, and do all that stuff. The important thing is in this frame, right? So in this frame, let me move this over a little bit, everything I need to spawn my grass instances. So I'm feeding in a mesh, right? So here's our primary input into this frame. We've got our mesh data, which in my context are the actual faces. So if I go over here, you see in this context, I'm working with instances. I want to convert those instances into actual mesh data, because if I don't, the way it will work here, let me see if there's a good way to illustrate this. Okay, so if I don't realize these instances, let's look at my first node in this frame. You see how I'm distributing points on all of these faces. And in my spreadsheet here, I have my point cloud, my point data. If I don't realize these instances, if I just bring the instances on in, you see how our data is different, right? I have 18 instances, one instance for each of my faces. Each of the faces that make up these cells. I'm just going to call them my cells. So there's 18 of them, okay? And I don't want that. The reason I don't want that is because what we're going to do is we're going to use these named attributes to preserve any of our rotation or scale or any kind of transformation data that we're doing on the individual grass blades. And if I am working with instances as opposed to actual mesh data, what's going to happen is all of these cells are going to share the same scale. Like all the grass in this cell will have the same scale and rotation. All the grass in this cell will have the same scale and rotation, as opposed to the individual grass blades, which I don't want, at least in my case, right? I want every single grass blade to have its own rotation and scale data. So that's an important thing. Realize your instances for this workflow to work. So let's bring this back. So I'm distributing my point cloud. I'm spawning instances on all those points. And then, you can change the rotation and scale on this node. I'm doing it separately. The reason I'm doing it separately is, let's see. So you can see, well, first of all, you can see I'm applying a random rotation, a random scale with this random value setup. So get a random value. In my case, I'm combining them. I could turn this into a vector, but I'm doing it manually, right? So I get a random float. I build a vector 3, and then I'm throwing that into my scale. Same with rotation. In the context of rotation, though, I'm only applying this to the z-axis, right? I only want to actually rotate this on the vertical plane, which, as you know, in Blender, z is up. So in order for this to work, what I've done is there's kind of two different contexts for working with geometry nodes with this workflow. So the first context is to actually build everything and get your scene the way you want, right? So I like this. I'm happy with how I'm actually laying out the grass in the scene. Maybe some of these grass blades are a little bit too small, but that's okay. But I have this Boolean flag. And right now I'm in preview mode. If I uncheck this, a couple things happen. One thing that happens is I'm explicitly applying materials to the different parts of my scene. So I have a couple of different materials. If we actually take a look at the Blender file, you look at the materials, I have these two dummy materials, foo and bar. I think foo's the red one, bar is the green one. It's arbitrary, it doesn't matter. I'll show you later why I'm setting these different materials. The other thing that I'm doing is clearing out this transformation data. If we go back to our geometry node setup, right, you can see scale and rotations are applied. Here, everything's cleared out. Everything should be facing the same direction. They all have the same scale. Let's see. Okay, so I found out that I was actually applying this rotation in two places, which is why, even though I was in preview mode, or I had preview mode disabled, it was not doing what I expected. So let me get rid of this. So I want to have a distinct node for applying my rotations. And then now, if I go, let's say down here, you can see everything is aligned the same direction. In other words, any of my random rotations are gone. So the important thing is I'm saving this scale and rotation data with this store named attribute node. So I have two different attributes that I'm saving: grass rotation and grass scale, right? So if I preview these nodes, you can see, in this case, I've got all of my different instances for each of my grass nodes, and I've got different rotations for all of these instances, right? See how these all differ? Let me fix this again. Drag preview mode, or it's actually this guy. Boom. Oops. Okay, I think I misspoke again. Let me... Okay, I was confusing myself a little bit. It's a bit involved, I realize that. But once you get the hang of it, like walking through it's actually a little bit more confusing to me than just doing it. But again, I'm storing the attributes, right? The attributes for rotating and scaling this. And you can see in our spreadsheet, I have all these random rotations applied on only the z-axis, and I have all these random scales applied, right? We're not seeing those right now because I'm not in preview mode, but if I go back into preview mode, we see all those things, right? See how, yeah, we've got the grass rotation and the grass scale. Okay. So now I have that data preserved, and I can go through, I can join my geometry to my actual scene. And then I have one final realized instances node, right? Which is necessary in order to actually apply these geometry nodes. So we're good to go. So let's actually do the work of getting this ready for Godot. So I'm going to go back in object mode. I'm going to duplicate this whole node setup. I'm going to move this to my staging collection. And I'm going to hide this guy. All right, so I've got my copy in my staging zone. I'm not at risk of, messing up or losing my whole GeoNode setup since this is a copy. So I'm going to apply this. Okay, so I applied it. Let me back up. So the whole reason, so I've got my copy. Let's move this to staging. The whole reason we have this flag, this preview node flag, is, I'll hide the original, because I want to clear all of my scale and rotation information and then apply these different materials. And this is actually the setup I'm going to apply. So now let's apply this. Let me go into edit mode, grab everything, and I'm going to press Control P, I'm going to press P and separate by material. So now, this is why I had those distinct materials. Now I have the grass isolated from everything else. And you can do this however many times you want with different materials. There might be a different way to quickly isolate objects from an applied GeoNode setup. This is just the way I found, and it works, so I'm sticking with it. So I've got my grass, and I've got my actual, platforms. So I'm going to call this platforms, and I'm going to call this grass. And now what I'm going to do for the grass is I'm going to go into edit mode on just the grass. And I'm going to do P again, and now I'm going to separate it by loose parts. And since I gave it this grass name, I have that nice prefix. I can tell what's grass and what is not, right? So here's the interesting thing. Those stored attributes that we applied in geometry nodes. If I go over to the scripting tab, in this tab, I changed this so I've got this spreadsheet view. I can bring it in here too, that's fine. So if we go to our spreadsheet, and let's click on an individual grass blade. You see that rotation data is saved, right? That grass scale and grass rotation data is saved. I have some other data that's not relevant for this example, but still means something to me for something else, right? And you can see I'm switching which grass blade I'm looking at, right? And I have all this data I need. So the reason I didn't want to have the actual scale or rotation data applied is because when you actually apply your geometry nodes, that additional transformation data is lost. So no matter what you have, like if you have a node setup that's changing the scale and rotation, when you apply all of that, it's going to be cleared out. You're going to have a scale of 1. You're going to have rotations of 0. You're losing all of that information. But because we stored this in the actual attributes for each of these objects, we can write a simple-ish script to bring that information back. So I'm going to go over to my scripting tab, and I'm going to run a couple things. So I know that this is, involved, but once you actually get this workflow set up, hopefully you can appreciate how powerful it actually is getting this custom data from your GeoNode setup. And you could, set up a process to save this as custom properties and set up your own GLTF, like import pipeline to do everything for you. You can do something similar with this, with the node or the Godot pipeline extension I'm using, which we'll use here shortly. But in this case, I just have a script that's going to grab the grass scale and grass rotation and apply it where we would expect. So this first function, let's first go into our system console. I don't know if I can force this to stay in the front, so I'll move it over in a second. But I'm going to make sure I've got all of my grass blades selected, and I do. And this is going to loop through everything in my selected objects. And if it is a mesh type object and it has a grass rotation data attribute, which in this case we do, grab that attribute and then apply it to the rotation of the object. So let's run this. Oh, first, before we run it, I've got all my grass blades selected, right? But notice how their position is all zeroed out, which means their position is actually at world 0. So if I were to rotate everything, it's not rotating as you'd expect. It's not rotating, relative to its own origin because, well, the origin, see this orange dot, is zeroed out. So what I'm going to do, in my case, I can press Alt-S to reset all the origins, or you can go to Set Origin, Origin to Geometry, right? And then I can apply those rotations. But the first thing that I want to do, actually, is I want to move the origin down a little bit, which is safe to do because all these objects right now are the same exact scale, right? So I'm going to move only the origin. Again, I've got hotkeys and all these extensions to make my Blender life easier. The native way to do this would be going up to Options, Affect Only Origin, right? That's basically what I did with my hotkey. I have it set up to my mouse. I've got all these cool macros and stuff set up, which I can go into in another video if people are interested. So I'm going to move this down a little bit, kind of where I would expect it. And then boom. So now all of those objects have their own unique locations. So now we can go back in here and run this script. Look at that. Okay. So it might not be super obvious, but you see how now all of these have their random rotations applied again. Yes, there's a much cleaner way of doing this. I could create an add-on to do this. Maybe I'll do that eventually. But for now, I'm just doing this manually with the script, and I'll have the script pasted in the description. So now let's do the same thing for the scale using that grass scale attribute. Boom. Okay. So we have, if I were to, let me just move this to a new collection just for kicks. All this grass, right? If I were to select any one of these grass blades, they all have their own distinct scales and rotations. So let's do Shift-G, grab everything in this collection. And then now I've got my original grass prime mesh, right? This is going to be the actual mesh that we're using in the multi-mesh. So I'm selecting this last. I've got all my grass selected. I'm going to do Control-L, link object data. Oops. And you see these objects are all linked. But because I set those individual transformations, to the origin of each of these objects, or sorry, to the scale and rotation of each object, this data is linked, but I'm still overriding those variables on these individual instances, right? 154 objects linked. So it's really cool because, obviously in Blender I can go in and change things, and boom. So now to the more interesting part. So I'm just going to do a couple things to make this all look pretty. I'm going to assign a material to my ground plane. I'm going to go into edit mode, project from view. I'm I'm going to go back into UV editing and then just give this a nice grass texture. I can also do fancy stuff like this. If I want to distinguish between the individual cells, I can use fancy plugins to do something like that. Cool. So we can distinguish between all the individual cells pretty easily. So now what I'm going to do is I'm going to go back over to Godot. Spoiler alert, here's it actually working. Yay. Let's reset and let's grab a link to the material that I want to use, Command-Shift or Control-Shift-C. And then with our Godot pipeline extension, let's set the material, boom, and make sure we do that for all the grass as well. Boom. And then if I were to, inspect all this data, make sure that I have the material set, great. Now I'm going to grab all of the grass and I'm going to go to Multimesh here. And I'm going to grab my path to the directory I want to store the grass multimesh. Command or Control-Shift-C. Just throw on that path and then say grass to .res. Let's set that. I'm going to hide my original one. And then let's export this as, in this case, I'll just do multi-mesh test. So everything that's visible in this scene should be exported. Let's do that. And then now, if I look at that new scene and make sure, yep, so I've already got the path set up, the import script that I need for the Godot pipeline, and I did that automatically through the import defaults, scene, import path. This is something that that Michael just pointed out in his latest video, showing a quick way to do this. So you can automatically set up custom import scripts without having to do it manually, which is really cool. So now if we drag this in, you will notice I have all of my grass, right? I've got all my grass. I got this dude. He's pretty cool. And I have 4 draw calls, right? So we have all of these different grass instances with all of their scales. This guy's really tiny. It looks like the material did not import correctly. Yeah, so looking at the actual Grass2 resource that was created, you see I've got this banding. That's because it's a low quality PNG from the new material that was added. So I want to use my own material, and you'll see that banding goes away. All right, not a big deal. But yeah, 5 draw calls, right? And you can see removing all of these grass instances only reduces that call count by 1. So yes, it's a kind of involved process, but the ability to define those custom attributes within the geometry node setup itself is pretty powerful, right? So there's always there's at least a way of getting data out of your geometry node setup and into the resulting mesh data, specifically the vertex data. And then you can do basically whatever you want. So this isn't necessarily applicable only to preparing your data for multi-mesh exports. It's also useful, in my context for like these platforms, right? these platforms are symmetrical, but I want to save like an index for each of these cells, right? So this one would be 0, and this guy up here might be 0. So just to better illustrate what I was talking about, the platforms, that we created from that apply geometry nodes setup, I've got additional data here as well. So you see I've got this cell index and then an is_mir Boolean. Notice how the corollary, right? So this is the mirrored version of, these two cells are the mirrored versions of each other. Cell index 2 is_mir is false. Cell index 2 is_mir is true. In this context, sure, there's a way to determine, which one's a mirror and which one isn't, just by, going through and looking at the total number of cells and doing some math there, right? But having that metadata, easily at hand makes my life easier. So I can do something like this, right? So I can select all this data, and if I want to do something helpful for my import into Godot, I've got another script which will do this. So of all of my objects selected, if the object's a mesh and it has the cell data or the cell index attribute, let's grab that value, and then if it's got the is_mir Boolean, grab that value, and then we'll rename the selected objects. So let's run this. I don't need to actually select it to run it. It's just a force of habit. But notice cell 0. In this case, I did this before, so I've already got a version. So let's just look at these. I've got cell 0 and then cell mir 0, cell 1, cell mir 1. So yes, I could save this as, custom properties, and then again have my own import logic or my own import script for Godot that does work for me. There's also a way to do this with the Godot pipeline, where you can set up a parameter file, and then this will automatically kind of map this data, serialize this data for you onto your scripts. But just having a kind of quick and dirty way to rename this data, and then I can just on Godot's end easily loop through all of these nodes. And with this kind of encoded name, I can perform work on it. So just to demonstrate the pipeline again, let's show all of the graphs again, and then export this for Godot again. And boom, I have all of my renamed cells, or all my renamed platforms, with one multi-mesh, with all my transformation information. So that was a long video. I know that there's kind of a lot that I threw at you. Let me know if you have questions about this. I'm sure you'll have to go back and rewatch this a couple times. Hopefully I didn't ramble too much, but yeah, I'm curious to see what you guys do with this. It's pretty powerful. If there's an easier way to preserve this transformation data in a way that's multi-mesh friendly, let me know. That's the workflow that I discovered. And the more I've been doing it, the faster it gets.